So hello everyone, this is lecture 15 for the atomic physics. In the last lecture we were discussing the LS and JJ coupling, and we were seeing that how can we write the spectral terms for the multi-electron systems, and we were studying the Beats method for the equivalent electrons, and we were discussing this that how to find the ground state. Okay, so we have seen these two examples. This is for D2 and D8. We have seen that how to find the ground state. That is simply you just need to fill all the electrons, and you need to calculate the L max and S max, and then if it is more than half filled, then J will be L plus S, L max plus S max, and if it is less than half filled, then it will be L max minus S max. J will be okay. So simply just fill them, and you will check for all the electrons. Means take the sum of ml for L. Means for this is for all these 5 it will minus 2 minus 1 0 1 2 will give you 0. Then these ones, this one, this one, and this one will give you minus 2 minus 1 will give you minus 3. So mode will be 3. So L max will be 3, and S max is simply means these 3 columns will give you 0 because plus half minus half plus half minus half. Only these two contributes, it will be 1. So S max will be 1. It is more than half filled, so J will be simply L max minus L max plus S max. So 3 plus 1 4. You will have J equal to 4, and L is 3, so it will be F, and S is 1, so multiplicity will be 2S plus 1, that is 3. This will be your ground state. So that's how you can find them. And similarly you can solve these examples also, F3 and S1, and see if you are getting that these orbitals are completely paired up, that is S2 or P6 or D10, then you will always find the ground state as 1s0. So you must remember it, like S2 you will get, P6 you will get, D10 for that 1s0. Try to calculate for P1, P5, P2, P4 in the similar manner as we did here, and these will be their ground states. So this will be a very good practice for you. Try to solve them. And there are some more examples like D1, D9, P3. So it will be 2D 3 by 2, 2D 5 by 2, 4S 3 by 2, D3 4F 3 by 2, D7 4F 9 by 2, D4 5D 0, and D6 is 5D 4. So you just you can try them. Okay, this will be a very good exercise. Now next is the LS configuration of ground state. So we need to write the configuration for them, and we need to find the ground state for all these 4. So first we need to write the electronic configuration, only then we can just find the ground state. So for 12 mg it will be simply Z will be 12. So number of electrons are 12, so we can fill them 1s2 2s2 2p6 3s2. So these are filled. So we know for the completely filled orbitals you will get always ground state as 1s0, and it will be maximum 3, and will be 3 3 1s0. Similarly for 13al you will write 1s2 2s2 2p6 3s2 3p1. So you need to write the ground state from this 3p1, and you know how to write for the p1. It's a simple 1 electron. So S max will be simply half, and L max will be, this is minus 1 0 and 1. So you will get only this minus 1, that will give you 1. So L max will be 1 and S max will be half. So it is less than half filled, so J will be simply L max minus S max, that will be 1 minus half will give you half. And as L is 1, so that will be P here, and the S max is half, so 2S plus 1 will give you 2, so multiplicity will be 2. So this will be a ground state for 13al. Similarly you can find for 17cl, and 18ar will get all the orbitals completely filled. So ground state for 18ar you can directly write, that will be 1s0, or you can write the quantum, sorry, this principal quantum number, that's 3 is also here. So you must remember this. Now there is one more thing we need to discuss here. If we are getting triplets like 3p 0 1 2, these are J values 0 1 2, so they will be in this order, 3p0 3p1 3p2. So as we have find it that in the doublets we have find it the energy difference, so here also you can find the energy difference. Okay, so that will be, we will use this formula, spin orbital formula. We have discussed this already, a by 2 jj plus 1 minus L plus 1 minus ss plus 1. So if L and S will remain same, means this multiplicity will remain same and this L will remain same, that is P, then how you can find this difference? This is J is different in all these 3, 0 1 2. So you will just first, let's say this is your J plus 1 and this is your J, so EJ plus 1 minus EJ means difference between the two consecutive J values, so you need to find the difference. So EJ plus 1 minus EJ, just substitute the value, L and S will remain same, so they will cancel out. So it will be a by 2 J plus 1 J plus 2 minus J plus 1. From here take the J plus 1 common, it will give you J plus 2 minus J, so J will cancel out, you will get 2, and 2 will give cancel out this, so it will give you a J plus 1. So difference between the two consecutive will be simply, this is the higher order, so that will be a J plus 1. Means if it is this 1, so it will be a, and if it is between this 2 and 1, then it will be 2a. So that's how you can just write. So j plus 1 is simply the higher one, means if you need to find the difference between these two, this will the higher one will be 1, and in these two higher one will be 2. So that's how you can write here, that will be the difference. So you must remember this will be very much can be used in the questions. So p2 minus p1 will be simply 2a, and p1 minus p0 will be simply 1a. Now there are some selection rules you must remember for the transition in the multi-electron system. So del n can be 0, means these are nothing but electron dipole transitions. So they follow some rules, means that's how somehow their parity can change. So that's how these rules are formed. So you just need to remember these rules, that's all. So delta n can be possible 0, plus minus 1, plus minus 2, or plus minus 3 and all. And a is simply means this is L. So L can be changed as plus minus 1, and for the one electron system it must be plus minus 1, but for the many electron system it can be 0 also and plus minus 1. But normally you will encounter with this only delta L as plus minus 1 for the single electron system. So you must remember this. Okay, this will be a very rare case you will encounter in the questions. So and delta S must be 0, means multiplicity, if there is transition then multiplicity must remain same or spin must remain same between these two transitions. Okay, so you must remember this rule. And delta J must be 0 or it can be plus minus 1. So delta J must be 0. That doesn't mean that transition between 0 to 0 is possible. So this transition is not possible, but delta J 0 is possible, and it can be plus minus 1 also. So you must remember all these 4 rules. Based on this many questions can be framed. So let's see one question. This is, in an atom obeying the LS coupling, components of a normal triplet state has separation 20 and 40 centimeter inverse. Between adjacent components, there is a high state for which separation are 22 and 33 centimeter inverse respectively. Determine the terms for the two states and show that allowed transition with the help of energy diagram. So there are two states are given and their differences is given. So it is in terms of centimeter inverse. So we need to find all that terms and we need to show in their diagram that transitions which are possible. So let's say for this, means there will be a triplet state, something like this. They are saying that there is a triplet state like this. Okay, and this difference is given in terms of centimeter inverse. So that is the meaning of this question. So first for this 20 and 40, so we know, just assume that if it is a triplet then it will be 3 j values will be there. So it will be j plus 1, j plus 2, and all are consecutive. That's why we assume that they are j plus 1 and j plus 2. So the difference between the upper two will be simply j plus 2a, and between in the lower one it will be j plus 1a. From here we know this formula. So difference between this will be a j plus 2, that is the higher one, and between these two it will be a j plus 1. So this ratio must be equal to, that is given as 40 by 2. So this is the energy gap. It can be written in the centimeter inverse also. So it will be 40 divided by 20. So this must be equal to 2. So from here a will cancel out and you can calculate the j, that will be 0. Now see, we know j, but now we need to write s and l also. So how can we write s and l from j? So j is 0. So that means j can be 0, 0 plus 1, 1, and 0 plus 2. So 0, 1, 2. These three values are possible. So minimum value is 0, maximum is 2. We know how we get j. J is simply L minus S to L plus S. So L minus S must be equal to 0 and L plus S must be equal to 2. So, and there are two cases possible when L is greater than S and L is less than S. But here it is equal to 0. That means it doesn't make any difference if you take L greater than S or S greater than L. Okay. Both will give you the same result. So L minus S equal to 0 and L plus S equal to 2. That will give you L equal to 1 and S equal to 1. Similarly, if you take S greater than L, that will also give you same result. L1, S1. Okay. So L1, that means P, and S is 1, that means multiplicity is 3, and J possibles are 0, 1, 2. So these are the three triplets, means this is the triplet you will get in this state, 20 and 40. So here you get these terms for this one. Now similarly you need to calculate the spectroscopic terms or the triplet for the 22 and 33. So this is, again you will get j plus 2, j plus 1 as 3 by 2. This is 33 will give you 11, 3, and 11, 2 will give you 3 by 2 here. Again calculate the value of j, that will give you j equal to 1. Now j equal to 1, we again assume that it is j plus 1, j plus 2. So j is 1, so it will be 1, 2, and 3. So minimum is 1, maximum is 3. Now again L minus S equal to 1, L plus S equal to 3, minimum is 1 and maximum is 3. From here you can calculate, that is L will be 2 and S will be 1. So L is 2, that means D, and S is 1, that will give you multiplicity 3, and J values are 1, 2, 3. So this is the triplet you will get. So there is a transition is occurring from this triplet to this triplet. and these are the spectroscopic terms for these two. So we need to solve the transitions also. So let's write this 3D123 and 3P012 in the diagram. So 3D1, 3D2, 3D3, this is the one triplet, and 3P0, 3P1, 3P2, this is the another triplet. Now transition will occur according to the rules, or the electron dipole transition rules, as I told you. So what are the rules? Means first, multiplicity must be same, means delta S must be 0. So 3 to 3 transition is possible, so all have 3, here also multiplicity is 3, so transition is possible. Now delta L must be plus minus 1, so it must be D to P. Okay, so it can be in any P, but see, it is also given that delta J can be 0 plus minus 1. So here 3 to 2 is possible, but 3 to 1 is not possible because difference is more than 1, that is 2. That's why this 3D3 will go to 3P2 only. Here this D can go to the P and delta J is 0, that's why it is possible. And here 2 to 1 is possible because delta J is 1, so this transition is also possible. And here this 3D1 to 3P2, delta J is 1 and delta L is 1 and delta is 0, so this transition is also possible. And this 3D1 to this will be 3P1, so delta L is 1, delta J is 0, so this will also possible. And this is 3D1 to 3P0, delta J is 1, D to P L is 1, so that's why this transition is also possible. So these are the lines you will get. So that's how you must remember these rules, and that's how you can just determine them. In the next lecture we'll see the JJ coupling, that is a very small topic. Then we'll go to the G-main effect. So that's all for today. Thank you everyone.